Hey, year 11, new topic in fun maths methods. We are looking at what are called matrices. Now, this is in chapter number 7. It's not the start of chapter number 7. We're sort of moving halfway through and we're jumping straight to the matrices part of chapter number 7. So please don't sit there going, oh, what about 7a, b, and all those things before 7e? Don't panic about those just at the moment. We're moving straight to 7e and starting matrices. Now, I know some people have been pretty excited to look into this because it's not necessarily something that you may have looked at in the past. So it could be a little bit different, but bear with us. We'll try and explain what's going on with these things. What you need to know is ultimately what matrices look like. And it says here a matrix is a rectangular array of numbers, and the numbers in the array are called entries of the matrix. And so they've listed some examples here. So you can see there's like these big sort of square braces or brackets that are put around to the outside of the matrices, and inside the matrices you can put some numbers. Yep. Now, what you do need to know is that there can be matrices of different size or dimension. Yep. So the way in which we define the size of a matrix is to talk about how many rows a matrix has and how many columns a matrix has. Now, one of the things that you do need to know is actually what the difference between a column and a row is. So again, rows are the horizontal lines. How many things go this way? Yep, they're rows. If we talk about how many columns, columns are the things that go up and down. I remember those by like the things that hold buildings up. Yep, the columns of a building. So if we look at this particular matrix that's here, if we consider how many rows there are, there's a row here and there's a row here. There's 2 rows. Yep. If we think about how many columns are in this one, again, there are 2 columns of numbers. There's a column there and a column there. Now, to actually describe this particular matrix, we refer to them by how many rows they have, by how many columns there are. So that's the order we talk about them. How many rows there are and how many columns there are. So if I was to describe this one, it has 2 rows. Imagine that's a 2. And by there are 2 columns. Yep. So there's 2 rows by 2 columns. Yep, that's how we describe that one. Here, if we look at this one, it has, thinking about how many rows it has, it's got 1 row here, 1 row here. Yeah, there's only 1 element in each of those, but there are still 2 rows, and there is 1 column. So again, the way in which you describe these is the number of rows. So in this case, there were 2 rows by, there's 1 column. So the order of this matrix, we would describe it as a 2 by 1 matrix. Yep. This one here has 3 rows and it has 3 columns. It is a 3 by 3 matrix. This one here has 1 row and 1 column. It's a 1 by 1 matrix. Yep. Again, I cannot stress, you have to write how many rows there are first, and then by how many columns there are second. The order in which you write those is important. Okay, if you get those back to front, things are going to be not so good for your results. Yep, so I'd be definitely highlighting and putting into your brains that sentence there. First number represents the number of rows, and the second, the number of columns. Cool, cool, cool. Again, the good news is in maths methods, in this book in particular, we're only going to be looking at 2 by 2 matrices and 2 by 1 matrices. So they'll only ever be either this size or a column matrix here, which is got 2 rows by 1 column. So you won't ever see a 3 by 3, except in this example just here. All right. So, if you were to describe and talk about a matrix, you can give the matrix a letter. Often they use capital letters to represent these matrices. So again, you can define a matrix. So you might say, hey, I've got matrix A is equal to, and then actually put the matrix with the elements or the items that are in there. Yep, the entries. Now, not only can you define or describe the matrix by a letter, but you can also describe the individual entries that occur in each of the rows and columns. Notice if you call the matrix capital A, each of the items or entries that are in there are referred to as the lowercase of that matrix, whatever letter you gave it. And next to that, imagine that's an A. Next to it, we're going to have two numbers. We're going to have one number they're calling the I. Let me get a dot there. The I value, and the next one is the J value. The first number here is going to represent the rows, or the position of which row it's in, whether it's in row 1 or row 2. And the J value, which is the second little number, little subscript next to that, is going to represent which column it's in. Yep. So again, you can see here, if you've got the entry that's in row 1, so this here is row 1, and it's in column 1, it's referred to as A11. No surprises here. This one, it's in the first row, as you can see here, and it's in the second column. So this is A12, and so forth and so forth. So hopefully you can get your head around that. Likewise here, they've said, okay, they've defined this one as column matrix B. Because they've described it as matrix B with a capital B, each of the little entries that are in here is going to be by the lowercase, so that's why there's a little lowercase b. And again, remember these little subscript numbers. The first number, which is the I value, represents the row, and the second value, which is the J value, represents the column it's in. So again, this one here is in row 1, and it's in column 1. This one here, it's in the second row, in the first column, so it's B21. Yep. Pretty important to understand that. Again, you could be given a matrix and they could say, hey, what is the element or what is the item that's in position A22? You'd have to be able to go into here and look up what number's in that position in the matrix. Says here, a matrix is a way of recording a set of numbers arranged in a particular way, like you write down Cartesian points on coordinates. The order in which we put them is significant. So when we talk about Cartesian coordinates, we always write the x value, comma, the y value. Here, when you put the numbers in the matrix, the position you put them in is important. Yep. So if we look here, yeah, okay, both of these matrices are 2 by 2 matrices. They're the same size. They've got 2 columns and they've got 2 rows. They also have the same numbers in there in different positions. Yep. And because they're in different positions, these are not the same matrix. Yep. If we want two matrices to be the same or to be equal to each other, then not only do they have to have the same number of rows and columns, so 2 by 2 in this particular case, that's fine, that's same like that, but they also have to have the same entries in the same corresponding positions. Yep. So if this one here would have to have the 1 in this position here, it'd have to have 2 here, it'd have to have the 3 here, and the 4 here for them to be the same. Yep. Now, good news is, because we're in maths, you can do operations to matrices. So again, you can do addition, cool. Subtraction, cool. And you can do multiplication, excellent. We're going to have a look at how addition works first. Yep. So again, it says here, addition is defined for two matrices only when they have the same number of rows and the same number of columns. So what they're saying here is you can only add and subtract matrices if they are the same size. Yep, same order. So in this particular case, we've got a 2 by 2 matrix here. It's got 2 rows and it's got 2 columns, and we're adding another matrix which is a 2 by 2. It has again 2 rows and 2 columns. They're the same size, so you can add these together. Now the way in which you go about adding them is you add the numbers in the same positions from each of the matrices together. So here, this entry, the 1, gets added to the same position of the second matrix. So you do 1 plus the 0, that's 1. Cool, you'd write it down in a new matrix. Here you would add this element or entry with its corresponding position and another one. 0 plus negative 3 is 0 take away 3, which is negative 3. Here, 0 plus this one here, which is the 4. What's 0 plus 4? Yes, that's 4. You write it in the new matrix here. 2 plus the equivalent position of the second matrix, which is here, the 1. 2 plus 1, yes, it's 3. You write it in there. Now again, notice that when you add a 2 by 2 matrix together, the result is also a 2 by 2 matrix. It's going to be the same size matrix as what the original one was that you are adding together. Yep. If you have just a single column, 2 by 1 matrix where it's got 2 rows and 1 column, again, you can add it to the same size. This one's also 2 rows and 1 column. You would just add these values together, the corresponding positions. It's just indicating this here. If you had this position, you would add this one here. So it's A11 plus B11, that one plus that one. You'd write it at the top, and down the bottom you'd have A21 plus B21. You'd write those together down there. Yep. Subtraction, as I sort of alluded to, is the same sort of way. When the two matrices have the same number of rows and the same number of columns, their difference is found by subtracting the corresponding entries. No surprises there. Alrighty, really quickly with this example, let's see how this operates. We've got always make sure they don't try and trick you. Make sure it is the same size matrix. This is a 2 by 2 matrix. This one is also a 2 by 2 matrix. They're the same size, you can add them together. So what you're going to do, I would actually do the little matrix sort of brackets, and I would then start calculating it from there. Yep. So this element here needs to be added with this one. 1 plus 2, it's the 3. You'd write it in there. This one here, 0 plus negative 1, it's negative 1. You'd write it in there. 2 plus negative 4 is the same as 2 take away 4. You'd write negative 2 in here. 0 plus 1, write the 1 in there. That's where you get that answer from there. I think you guys should be pretty comfortable doing the addition here. Subtraction, again, as it said here, same difference, but we're subtracting them from each other. 2 take away 2, it's 0. Negative 1 take away negative 1, don't get your signs confused. Remember, if you are subtracting a negative, it's the same as adding. Negative 1 plus 1 is 0. Cool, we've got the answer there with that. See, it's not so bad after all. Oh, cool. You can do what's called multiplication of a matrix by a real number. So you can actually have a scalar number, so a number that is out the front of the matrix. If you have a scale number out the front, they're calling it k here in methods. If you have k, which is a real number out the front of a matrix, what it means is we're going to be multiplying that whole matrix by that scalar number. Yep. So let's have a look at this example here. You've got a scalar out the front of this matrix. This really means 3 times this matrix that's here. Now the way in which you do a scalar multiplication is whatever number is out the front, you can multiply it by each of the elements in the matrix to find the resultant matrix. Yep. So here what they're doing is if you've got the scalar k value 3 out the front, it's going to be 3 times this matrix, which is, to write it out, it's going to be 3 times this element. 3 times 2 is the 6. 3 times this one here, which is negative 2, is going to be negative 6. You'd write that in there. 3 times 0 is 0. and 3 times 1 is 3. So essentially you just multiply each of the items in that matrix and write the result in there. Yep. What's this saying here? Oh yeah, cool. If a matrix is added to itself, the result is twice the matrix. So if you had A plus A, so matrix A plus matrix A, it's the same as doing 2 times matrix A. Yep. Cool. Good. Oh, it says if you've got a matrix where all the entries equal to 0, it's called the zero matrix. Yep. So if you have a matrix and there's zeros in every position, it's known as a zero matrix. Cool. That might be worthwhile memorizing. Let's have a look at this worked example. Cool, it says here we've got two matrices. They've defined matrix A as this one here and matrix B as this one here. Cool. It says find the matrix X such that 2A plus X equals B. Ah, this is kind of like algebra that we did in year 10. Yep. So again, if you've got 2A plus X equals B and you want to find out what X is, you have to move this 2A over to the other side. Yep. So again, just remember how it works. If you have 2A and you want to move to the other side here, that's positive 2A. We need to subtract 2A from this side. Imagine that's an A. You need to do the same thing to this side. 2A. Imagine that's an A also. So subtracting 2A from this side, you're left with X on the left hand side. On the right hand side of the equation, you're left with B take away 2A. That's how they got that there. Given that we've rearranged it to this particular position here, we can go ahead and actually work out what B take away 2A is by plugging in what each of the matrices are. So the way you would do it is you'd write it out. X is equal to matrix B, so you'd write down what matrix B is. Here's matrix B, they've written it out here. That's just that part written out there. Take away 2 times matrix A. So they've written out here what matrix A is, which is from there. Yep. Now, the way in which they've calculated this, you could do it in one step, or you could do it in 2 steps. You could multiply out this scale matrix here, multiply everything by -2, and then add the matrices. Or what they've done here is they have just gone with each of the elements. They've done this one here, 0, take away 2 times 3 for the first one, which is -6. Then they've gone and done this one, -4, take away 2 times 2, which is this one here. -2, take away 2 times -1, which gives us this one. And then they've done 8, take away 2 times 1, which is this one here. However you go about doing it, you will end up with this matrix here. Next, the good news is that these things can be done on your CAS calculator. Yep. So looking at the class pattern, you might choose to have a bit of a play around with this today. What you'll do is you'll find that the matrices are in the Math 2 section on the keyboard. So here you'd go click on Math 2, and the matrices are this button here. It's like a little, it's got the matrices symbol and like little squares there. So you can click on either that one there to give you a 2 by 2 matrix, or there are these ones here. Now, if you clicked on, for example, this 2 by 2 matrix, click, look, it comes up here like that. If you wanted to add any rows or columns to that matrix to make it bigger, you just click on these buttons here, and that gives you more columns or rows. Yep. So if I was to click on, for example, this one here, it would give us more columns. It would pop it out and you'd have more over this side. Yep. So it's useful to press these buttons to check that out. Once you've got the size matrix you want, you can type in and click in to each of the spots to type in the entries for each of the items in the matrix. Yep. Once you've done that, you can do pretty cool stuff. You can store. So this button here is the store button. It's actually on your calculator. I think there's a button actually on your calculator. If it's not on your calculator, it's still in Math 2 section. It's that button that's there. Yep. So if you're looking for the store button, you can store it as matrix A. Yep. So you write out the matrix here using that matrix template, do the store button, store it as A, and it will set it as matrix A. You can do another matrix template, store it as B. You can define as many matrices as you like, which is cool. Now, once your matrix knows what matrix A is and what matrix B is, you can do pretty cool things like if you had to do matrix A plus matrix B, you don't need to type in all of these matrices again. You can just go, I want matrix A plus matrix B, so A plus B, and it will do the addition for you. How cool is that? Likewise, A take away B, type in A, take away B if you've defined them. Bam, calculator does it for you. Cool. If you had to do a scalar multiplication, like say 2 times matrix A, you can just go and type in 2A, for example, press enter, and it will do it for you, which is very, very cool. Yep. Have a play around with your calculator with those today on that. Alrighty, the last thing that I want to talk about today is multiplication of matrices. Now, it's going to be a little bit different than when we were talking about the scalar multiplication of matrices, which was pretty straightforward, where you just multiplied the number that was out the front of the matrix by each of the items in there. When you actually have 2 matrices that you want to multiply together, it is a little bit tricky to get your head around. Yep, and it will take practice to get these right. Yep, so I said the P word, you're going to have to practice these. Yep. So let's try and go through this as clearly as we can. You've got 2 matrices here. You've got matrix A is being defined and matrix B has been defined. Happy days. If you were then asked to calculate AB, we know as mathematicians that means matrix A, again, that's an A, multiplied by matrix B. They don't put the little multiplication in there, but AB means matrix A multiplied by matrix B. So you'd write out matrix A, you'd write out matrix B. We know that they are going to be multiplied with each other. Now, the way this works is you go across the columns and you go down the rows. Yep. So what happens is we're in this first row here of the first matrix, and we're in the first column of the second matrix. So what we're going to do, we're starting in the first position here, and we're going to go across this way, and we're going to start in this position here, and we're going to go down this way. So normally I'd be in the classroom and I'd have 2 fingers pointing here at the same time. So what happens is it starts off in the first position of the, and again, sorry, if you've got a 2 by 2 matrix and you're multiplying it by a 2 by 2 matrix, the result is going to end up as a 2 by 2 matrix. Yep. So ultimately you will be ending up with a number, a number, a number, and a number. Yep. When we multiply these two, we'll end up with a 2 by 2 matrix. So to work out this first item here in position 1, 1, you need to do this number here, number 1, multiplied by this 5 here. So you do the 1 multiplied by the 5. It's this number multiplied by this number. Then we are adding plus, this is where we go across the column and we go down the row. So we're adding on now this number, which is the 3, and we go down and we multiply by the 6. 3 multiplied by the 6. Oops. That's a 6. That's a multiplication. You can see it clearer there. Yep. So to get that, just that first item there, that's how you do it. You start that one, multiply by that one, plus that one, multiply by that one. So you're going across and you're going down. Obviously that will give you that number there when you calculate it in that position. Then what you are doing to calculate the next value over here, again, you're still going across this row, but instead of going down this first column, you'll be going down this second column that's here. So in this position, you'll be doing 1 multiplied by 1 plus, you go across and we're going down. So plus the 3 multiplied by the 3. Imagine that's a multiply. Yep. So you're shifting, you're still on that row here, but you shift across the column to do the multiplication. It's this one multiplied by this one, plus this number, and you go down by this one. Next, to work out these numbers here, you go, we're going to shift down to the second row. Where can I position it? Let's go to the second row there, this one here, and we'll do the same, but first of all, we're going to be multiplying by that first row, and then we'll shift over to the second row. So again, you start here, it's the 4 multiplied by the 5 plus the 2 multiplied by the 6. That'll give you that number that goes in that position, which is the case is that one there, 32. Again, for this second row, after you've done that multiplication by this column, it's going to be this row multiplied by this column here. So let's shift that across. We're going to go down this one. So we've got 4 multiplied by 1 plus this 2 multiplied by the 3. So you're going, as you're going across, you're going down. Yep. Now, I know it's a little bit tricky to get your head around, but it's just one of those things, once you get in the habit of it, I still, when I'm doing these matrices, I even put my fingers, I go, okay, it's that multiplied by that one, and then I move my finger, it goes across and goes down, multiply by that one. It's that one by that. I'd even do like the finger thing, yep. If that's what gets you through, so be it, yep. It's just practice, and you just have to do this over and over again until you just get that pattern of how it works. Yep, it's not natural, I acknowledge that, but there are times in maths where you're going to have to learn new things. Today's one of them. Yep. Alrighty, now, cool, so that there is matrix A multiplied by matrix B. Yep. Now, what you should know straight away with matrices is the order in which matrices are multiplied is important, and it differs. Yep. So here, where we've multiplied matrix A first, then that's multiplied by matrix B. If you were to do it the other way around, if you did matrix B first, multiplied by matrix A, it actually gives you a different answer. Yep. So please don't ever get confused in matrices and just go, oh, I've worked out what AB is, it's going to be the same as BA. It's not like just normal multiplication where you have 3 times 5 and you go, okay, that's 15. It's the same as if we did 5 times 3, that's 15. It doesn't work that way. Yep. The order is important in which things are multiplied. So that's where this note comes from. Matrix A, B does not equal matrix B multiplied by A. So the order is important. Again, that's already spoken about that. To find the entry in row I and column J of AB, single out row I in matrix A and column J in matrix B, multiply the corresponding entries from the row and the column, then add up the resulting products. Yep. So that's what we've done. Okay, here again, you can have, with multiplication, you can have different size matrices when you are multiplying. Yep. So here you've got a 2 by 2. You've got a 2 by 2, and here you've got a 2 by 1. Oops, 2 by 1. Yep. Now, here is how you can check to see if you can actually do the multiplication. Here we're doing matrix A multiplied by matrix B, which is AB. If we've got these inner numbers here, so I've written the order above. These numbers here are the inner numbers of this matrix. If they are the same number, then the matrix multiplication can be done. So that's a 2 there, that's a 2 there. Because they're the same number, you can actually go ahead and do this multiplication. If this was, for example, a 3 by 1 matrix, and you had a 2 there and you had the 3 by 1, they're not the same number. You wouldn't be able to do the multiplication of those matrices. Yep. The other cool thing is if you write down the order of these matrix, so you've got the 2 by 2 and you've got the 2 by 1, these outer numbers, this 2 here and the 1, will be what the resulting matrix will be. So when you multiply these together, it will result in a 2 by 1 matrix. Yep, so it's useful to know as well. Cool, so let's actually go and do the calculations. So again, we're going across the column. Sorry, we're going across the row first, sorry, and down the column. Yep, so here you would do 2 multiplied by 5 plus 4 multiplied by 3. So we're going across and down to get those. And then obviously in the second row of the resulting matrix, we're going to go across this second row. There's only one column. Yep, so it's not you don't have to move around. This one here is going to be 3 multiplied by 5 plus, we go across and then down, plus the 6 multiplied by 3 to get that there. You can see it is a 2 by 1 matrix. That is the result that's there. Good news is, again, if you defined these, so this is different numbers, but if you define two matrices, cool, and you actually stored them, so using the store button I spoke about before, stored this one as matrix A, stored this one as matrix B, you could type in AB, and it would do the multiplication for you. Matrix A multiplied by matrix B, and it will do it. Happy days. Cool, cool, cool. Likewise, it's very easy then to do matrix B multiplied by A, as we know they're not the same, and you can see the result there of that one. Thank you very much for listening. You do have some maths to do. I wish you all the best with this result. Bye for now.